Hello, and welcome to Pivot3's partner training. Today we're going to walk through the Pivot3 platform and how the advantages can really help customers when they're looking at hyperconverged infrastructure versus, say, other hyperconverged platforms out there or that traditional SAN storage architecture. So first thing we're going to talk about is some of the key advantages of Pivot3. Performance, we're based on NVMe flash storage. We've integrated storage quality service. It's far more advanced than our competition, as well as the fact that we act like a SAN. So we get to take advantage of all the performance that a traditional SAN has, and a lot of the features the traditional SAN has, and some of the flexibility, while maintaining all the advantages of hyperconverged. Next, we're going to talk about efficiency. We're going to talk about how we have extreme amounts of compute efficiency, so we don't take a whole lot of resources to operate our HCI, as well as the storage efficiency, which really lets us do a lot more with a lot less hardware. Next, we're going to talk about scale, how we scale out the boxes. You get predictable storage, performance, and sizing, as well as you can be very flexible with how you scale that out to include things like compute-only nodes or storage-only nodes or HCI nodes. You can really mix and match to whatever makes sense for that customer's environment. And we're going to talk about the enterprise data services, snapshots, replication, things you normally expect in a data center SAN. You're going to be able to continue to keep those. And then also how we deal with content agnostic storage. That's really important when you're talking about things like VDI, where the deduplication is already kind of built into your link clones. You don't get to take advantage of a whole lot more dedupe or video, anything like that, where it's compressed or encrypted, non-compressible data. Lastly, swap, space, weight, and power. You're going to talk about basically how we're able to reduce footprint, reduce overall total cost of ownership. Those are all kind of those key features. You should see that kind of threaded into this presentation. First, we're talking about the conventional hyperconverged architecture and how that relates to Pivot3. So this conventional HCI is going to be your Nutanix, your vSAN, your SimpliVity, and then to a point HyperFlex from Cisco. This is kind of how they operate. You have each server has dedicated disks on that server. The hard drives that are located on that disk have to not only support the VMs that are running local to it, but they also have to support replicas from other nodes. So when a VM living on that node writes, it writes to that local hard drive, and then has to then make 1 to 2 copies of that onto other nodes, depending on the protection level you're applying. This was a cool idea, but realistically, it came about because they were trying to figure out how they make highly available storage. They can make that happen as quickly as possible. So replication was kind of the only way to do that quickly without having to really break down a new storage subsystem. So that's kind of how that works. The disadvantages of doing that is if you move VMs, you then have to storage remotion those VMs. It happens automatically, but it's still a lot of back-end workloads that have to happen in order to keep that storage local to the VM workloads. You're also going to have high CPU overhead. So as more replication jobs start happening, deduplication and compression starts happening. Again, if I'm making multiple copies of this data to keep it protected, and I'm losing storage efficiency significantly, right? If I have to make 2 copies of it, then I only get 33% usable storage on that platform, plus whatever other overhead is required by the HCI technology. So at 33% usable storage, I then have to turn on deduplication and compression to ensure that I actually have enough storage to do what I need to do. Hope that data can be deduped and compressed, and then I have to go impact that CPU on the system that's being shared with my virtual servers in order to complete those tasks. So there's a lot of CPU overhead in a lot of these HCI platforms, and it all stems from being inefficient with the storage because they didn't want to go build out a different subsystem to make HCI work. Pivot3 is very different, and the reason why is we started in 2002. we actually spent 4 years building that exact storage subsystem, making a software-defined storage platform built for a distributed style storage architecture. In fact, our first platform didn't include the compute, it was purely storage. And we did that to take an x86 box and really make a low-cost storage solution for some customers. At the time, it was actually focused more on video surveillance customers, ones that needed something that could easily scale up, get throughput, get a lot of IOPS out there, but also that could be really simple to use and scale because you had a lot of physical security people that were managing these systems. So Pivot3 took that lineage, threw hypervisor on it back in 2009, made the first hyperconverged platform out there. But also what makes us very different is those boxes come together, and all those disks, they pull into one large SAN-like appliance. So a VM is written to a large pool of storage. You create volumes on that pool. VM is written to one of those volumes, and if the compute moves around, it acts like a SAN. It stays put on the storage, and the VMs can be motion however they like. There's a lot of advantages to having that. We are block level, so you're able to do things like create volumes, mount them to existing physical servers, which allows us to be more aggressive in how we work with customers, right? We can use compute-only nodes because we have the ability to mount our storage to servers that that don't have their own storage built into them. It also lets us be very, very efficient because of the way we pull together. We natively use that scalar ratio coding you see there at the bottom. That's a Pivot3 patent that we hold, one of over 30 that we hold in our software-defined storage portfolio. You'll see that scalar ratio code is actually referenced by Google and multiple other large integrators, cloud providers, for how they built their own ratio coding for their different platforms. That scalar ratio coding is key to what differentiates Pivot3 over all the other HCI. And again, the reason being is we spent those 4 years to go do storage right before we created the HCI, instead of trying to make wrap a replication subsystem with a file system around it to try to get something out to market. We really try to build the solid storage subsystem underneath. Next, we're going to talk about the performance piece of a single tier architecture like you're going to find again with those conventional HCIs versus what you're going to see with Pivot3. So in your conventional HCI, you're going to have an SSD tier, and then you're going to have a persistent layer underneath. So you're going to have simple caching and then long-term storage. With Pivot3, you have multiple layers of caching and persistence. First, we're going to start off in memory. Inside the memory, we actually align the blocks to get them into 1 meg chunks so that they fit in the SSDs really well, coming down to the NVMe flash. Those 1 meg chunks are able to fit in there nicely, allowing all that storage transition to happen really, really smoothly. I don't have to go try to merge these into chunks later on. It all happens in memory, comes down, and the placement's really, really smooth. Optimizing the disk, optimizing the lifetime of those disks, all that happens right in the memory. NVMe, from that point, we carve that up into multiple sections. We have a section of the NVMe that's built for read cache, write cache, read ahead capability, as well as persistent storage. And we do that because as data starts to move down to the higher capacity tiers, we use our quality of service to say, hey, we're going to automatically read ahead data. And if that data is going to continually need to be used because it's a mission critical style volume, then we're actually going to start moving that data up into NVMe or making copies of that data in NVMe to ensure it's able to live there to give you the most optimal performance. In a VDI environment, this is critical because it allows those master desktop images to really just kind of live in that NVMe and never have to be read from a lower level tier, giving us those guaranteed sub-millisecond latencies on the NVMe, in the VDI environment. We talked in the first slide about efficiency, and then how we're more storage and compute efficient. This slide really kind of breaks that down for you. When you're looking at one of our competitors, you're going to see either when you want to call RF or FTT, depending on the technology you're referencing. Your FTT1 is going to be that 50% line. And again, this is without any other overhead. You're talking about FTT, you're normally talking about an additional 30% for swap space to be left to be opened up as well. But this is just purely just replicas. I'm going to have 50% usable storage. And with that, I can lose a drive. If I lose another drive, another node, I can lose data, right? I can lose a host, but I can't lose anything else, right? At that point, I am very unprotected until I do a whole bunch of rebuilding operations, which requires even more storage set aside for that rebuild operation. To get to a level of protection that Pivot3 has, you have to be down at a 33% level, meaning that just to run your system, right, I'm losing 66% of my storage that I have to have just sitting there just so HCI can operate. I'm spending a lot of money for highly available storage because I have to buy all those disks just for replication space. Pivot3, because we use our erasure coding underneath inline, it doesn't have to be, it's not post-process erasure coding, it is straight up scalar erasure coding underneath. That's just how we write our blocks. We start at 66% usable storage at 3 nodes. For the same 3 nodes, I'm at the same protection level as your FTP2. I'm able to lose 3 disks simultaneously, or a disk and have another failure as well, or sorry, a node and have another failure as well. It gives me a very high level of protection right out the box with three appliances. I don't have to get up to 5 appliances just to be able to reach FTP2. I can do that at 3. As well as the amount of CPU overhead required to do that is very, very small. And the reason why it's so small is we actually, when we create a volume, we map out where all that data is going to lie eventually. So when data starts coming in, it already knows where it's going to land. So we don't have to worry about having a whole bunch of CPU overhead to handle moving data around constantly, or trying to do post-process this, post-process that. It's there, it's locked in, it's ready to go. So here's another slide on that compute piece we mentioned. Most HCIs, when you get to turn on everything to let it fully operate for a data center environment, you end up utilizing about 30% of the CPU. Some solutions are less, some are more. Turn on deep and compression, it can be even higher than that for some of those. I've seen them as high as 40, 45% CPU utilized just for running HCI. At that point, it's really difficult to say that HCI's got value when I only get to use half of my CPUs, so I have to buy twice as many boxes to do the same amount of work. Does it really have that much value? With Pivot3, we're running around 8%. That 8% is extremely low. Honestly, that same 8% is pretty close to what's utilized with just standard iSCSI or fiber channel coming from a SAN, just to manage all the I/O traffic workloads going on. It's a very, very low overhead. So you get to really maximize how many virtual machines you can run or virtual desktops you can run on that node without it being wasted by the HCI technology. Next, we're talking about our quality of service. So I mentioned the different tiers of storage. We utilize those tiers very well with our patented quality of service. What that's meant to do is it allows you to say as the customer, hey, this data is more important than this data, or this virtual machine is more important than this virtual machine. So as they're running, they're going to run full speed, full bore, go at it, until something that you said is more important starts to hit a constraint. If it starts to hit a constraint where it's trying to ask for more resources than are available, then we're going to go take that anything that's in a lower level, we're going to start restricting that down. And there's 5 tiers built in there. So obviously we start with the bottom tier, we start restricting, and then maybe in that tier, and gradually go up to ensure that those higher level tiers meet their SLAs. We don't restrict anything until there's contention. So everybody can run full speed until we're at a point where there may be contention between higher level virtual machines. Also, we talked about the flexibility of the Pivot3 architecture. Again, this all stems from that scalar erasure coding. Because of the fact that we're able to pull that storage out, we're able to not only do our standard hyperconverged appliance, which is going to be your compute, your storage, and your storage networking at the back is all going to be in a simplified appliance. You have your hypervisor running there as well. But then we have the ability to add just data nodes. Say I'm in an environment where I have enough compute, but I need more storage. Pop a data appliance in there, and you're able to just scale out the data side. It allows you to have a much lower end CPUs, much less memory in those boxes, but yet I'm able to scale out the resources that I need at that time. I don't have to go buy a full high-end HCI box. I can spend significantly less on a lower end data appliance. And same thing goes for compute. This compute nodes are fantastic for VDI because VDI is CPU constrained application normally. So I'll have plenty of storage IOPS because of the NVMe up front, and then I'm able to go add compute nodes on it to give enough CPU to go handle those workloads. So based on, I'll take an HCI cluster, add a couple more compute nodes. Those will all pull together. They'll all sit inside one VMware cluster. You'll be able to access all the storage, be able to perform all your workloads, all your virtual desktops, and to the administrator, it's really no different. Next, you have the just GPU-enabled nodes. Those are, you can put GPUs in almost anything. The only thing we don't put them in is the data nodes because they don't have a hypervisor on them. Part of the cost-saving technology in the data node is they don't need a hypervisor. It's all bare metal. So those data nodes those GPUs go into compute nodes, HCI nodes, whatever you need. Next, we're going to talk about just the flexibility of the configurations. So by default, we have we kind of certify a simplified appliance. That simplified appliance has 6 NICs. By default, we do 6. 2 of those NICs are for storage traffic. We have a SAN 0, SAN 1, 1 NIC dedicated to each. And then we do 2 NICs dedicated to ESXi host management, and then 2 NICs dedicated to VM network traffic. That is Pivot3's default preferred configuration. And we do that because we don't want to run into those issues where vMotion starts taking over bandwidth from your virtual machine networks or something of that sort. So we try to isolate those NICs as much as possible. With that said, if you are having 6 NICs per box, that could then raise costs on networking. So sometimes we can't do that, and so we have the option to go down to 2 or 4 NICs, depending on what you want to do. But 6 is our default. And with those 6 NICs, because we are running on Dell, we're running on an OEM platform, either Dell, Lenovo, Supermicro, depending on your choice. We're physically constrained. We only have so many spots in the servers. So in order to get a second graphics card, and to normally have the option for 1 graphics card, PC over IP offload card, 256 terabyte and a half of memory, and then dual 1220 core CPUs. Those are our default configurations. Going beyond that, we have other options that are semi-custom. They're not in our default price book, but they're absolutely fully supported and tested can be configured for the customer. We try to limit how much is in our default price book. Some of those options are going down to 4 NIC ports. Basically, merging some of those together, however the customer wants to merge them, we can do that. We can even go all the way down to 2 NICs if that's what you prefer. We could go to a 40 gig NIC if the customer would prefer that instead of 10 gig. Once we're able to drop down those NICs, we then have enough slots to do 2 grid cards if that's what they want. We can do fiber channel cards for connecting to external storage devices. We can do dual 24 core CPUs. That's something that we found very, very valuable in those VDI environments that are CPU constrained. We add these higher end CPUs. Lets you get a lot more CPU per server, really lowering those costs down. Okay, next we're going to talk about how we manage the system. So we've already kind of walked through the performance piece. We've walked through how it scales. We talked about the flexibility. Now let's talk about how easy it is. Pivot3 is managed through a vCenter plugin. It's pretty simple. It's all HTML5 based at this point. If you need to, you can also, we have a version of that plugin that could be installed locally onto a jump box or a laptop or whatever you want. But it's exactly the same plugin that lives inside vCenter. By default, most customers just run it right off vCenter, and it integrates right to the vCenter web client. From that point, it's just a simple HTML5 plugin you click on. You're able to go create storage. You're able to modify quality of service memberships. You create a new volume. We try to automate a lot of those tasks, like creating a volume you'll see in the screen here. If you at the bottom there, you click the checkbox, give a data store name. When you go to create that volume, it's going to automatically create it, give it the policies you define there, as well as go into vCenter, rescan all your data store, rescan data stores on all your hosts that are inside your access group, and it's going to go format it, the VMFS file system version you choose, and it's going to go mount it to all those hosts. So we're trying to take some of those additional steps out to make some of those things even easier. All right, so now we're going to talk about a little bit about resiliency. I know I mentioned a little bit ago. We have that FTP2, or RF3, depending on which technology you're talking about. But basically, we have the ability to lose, depending on the level you choose, up to 5 drives or a node and 2 additional drives, all at the same time, right? They can be failed out of any of what we call a virtual performance group. That virtual performance group is just a grouping of HCI nodes. I can always lose more compute nodes beyond that as well. So just the nodes that are actually delivering storage to an individual pooled storage resource, I'm able to lose 5 drives or a node and 2 additional drives simultaneously. Again, out of that, I can still lose more, like a compute node, something along those lines within that VMware cluster, and still be fully operational. So we're going to talk about a couple of different scenarios. We mentioned how that flexibility. Here we're going to talk about if I have a flash storage pool, and this is the perfect VDI example where I need to add more servers. I'm going to add more physical servers, more compute nodes. They're going to go mount into that storage. Everybody's going to live inside one VMware cluster or 2, 3. When I say everybody lives in one VMware cluster, I'm saying you have that ability. Not that you have to. You can still split it up into whatever primary clusters you want to split it up into. We don't really care. But they all access that same storage, and they're all able to run those shared workloads. Next, we're going to talk about an environment where I have plenty of compute, I just need storage. Same thing, I had storage-only nodes. Those build out, those virtual machines have access to the combined storage of all 7 servers in this case. So I could have one VM in there that that needs 100 terabytes, and all the other ones need 1 terabyte. And that's okay, even though the host that's local to that one VM, it only has, say, 24 terabytes in the box, because the total pool of storage is more than that. That VM can access as much as it needs to. It's not limited to what's local to its box. It has whatever's in that pool of storage. Next, we're going to talk about if I have multiple pools, right? I just told you the VM could access whatever storage is, however much storage is in that pool. Well, if I have 2 pools, that VM can access storage from both those pools. It's not just even what's located inside its virtual performance group. It can go reach out to other ones as well. So I can have multiple virtual performance groups of HCI nodes that are side by side together. Those volumes are all meshed between them. So virtual machines can access, or the compute of those ESXi hosts can access any volume from any of those virtual performance groups. Next, we have how we interoperate with an existing data center. Because, again, we're SAN-less, we're block storage, you can take a volume, you can mount it to external servers. Say you have workloads that can't be virtualized. Say you have some Linux servers or some database servers that just don't make sense to virtualize. You just really take advantage of the raw CPU. They just need that much CPU performance, or just they're running Windows NT or Windows XP, whatever, or Server 2000, whatever it has to run. You're able to go mount volumes to it via SCSI and mount away, and it's good to go. And say you have existing storage, you want to mount it to our ESXi host, go right ahead. It doesn't affect the way we manage our system. You're able to fully utilize the existing storage, mount that storage out to anything else you want to mount it out to. Shoot, we can even mount those storage. We can RDM it into the ESXi, or we can mount it directly into SCSI, mount it to a Windows VM or a Linux VM and running on those ESXi hosts. Fully flexible. You can treat it like a traditional SAN. The is really great for going into a data center that has an existing solution that maybe only parts or pieces of that are gone end of life, but not everything, right? So I'm able to just kind of interoperate with what's left there. And then as things start to end of life, maybe I add a couple more appliances, right? A couple more HCI nodes because or even just compute nodes if I had to go pull out some old servers. I have that flexibility because I can interoperate with the data center instead of having to be a silo. Here's just a couple pictures of that vCenter plugin again. These are a little bit older pictures. The icons have been updated a little bit, and this is actually still the Flex version of the plugin. It's all now HTML5, but it just gives you an idea. You get a quick little dashboard of when you log into it, saying, hey, here's your environment. Everything's good. You haven't degraded. Maybe a hard drive failed, something of that sort, or then it tells you what your storage capacity is, where everything is falling right now. Quick little dashboard, give you an idea how your environment looks. And then we even go all the way down to getting you a dashboard on the network. If you want to just say, hey, do I have any network links down? It'll run a real-time scan on your system for you and identify any of those storage networking links that are giving you a problem. And you'll be able to say, hey, yep, this host right here, stand 0 port is either disconnected or running slow right now when you go talk to network guys, get that figured out. So lastly, here's kind of the use cases that Pivot3 is actively engaged in. Database servers, because of the fact that we have quality service, it really allows those databases to run in the same environment as almost anything else. So it's really optimal for that environment because most of the time people are trying to get dedicated storage arrays or dedicated compute to run their databases. We're able to kind of mix all those workloads together and do it in a protected manner. Unified communications, VDI, obviously. Tactical Edge, we have a hardened version of this as well. It comes in short depth appliances that are great for deployable kits. We work with multiple DoD agencies on these deployable kits to get them a 2-man lift to run full data center capabilities right inside a little rugged case. Multi-tenant private cloud, we've been working with some multi-tenant private cloud organizations out there that are trying to build out the multi-tenancy for multiple releasable networks, those types of things. We're also doing data analytics, again, because we're so good at being able to ingest a whole bunch of data from the video surveillance background that we've had. Data analytics looks great because we're able to ingest a whole lot of data. Our Splunk reference architecture will lay that out for you. I think we perform about 6x what is required in a remote acuity array, what was required for Splunk. So it's very, very powerful. It does really well at ingesting that data and analyzing it. And then last but not least, the video surveillance, Internet of Things apps. So those are kind of the use cases that Pivot3 is really good at kind of focusing on right now. Realistically, it's nearly everything in the data center. The only thing that we don't focus on is those big data Hadoop style architectures that don't really want to be virtualized. We still try to focus in virtualized environments for the most part. Not pure non-virtualized environments is kind of an area that we stay away from. So thank you again for your time. I appreciate it, and hope you have a good day. Thanks.